Welcome to Student Center School. I am your mathematics teacher, Mr. Ochulo Humphrey C. It is time for mathematics. And the topic we shall consider today is different types of numbers. Different types of numbers. We're starting with numbers because in mathematics, numbers are very important. They play very important role in mathematics. That's why we're starting with numbers today. The first to start with is the definition of number. What is a number? A number is a symbol used for counting and measuring. Different types of numbers exist in mathematics. They include 1. Whole numbers. Whole numbers are numbers without fractions. It means they don't have fractional parts. They can also mean positive integers along with 0. Positive integers along with 0. They are like the parents of other numbers. Examples of whole numbers are 0, 1, 2, 3, 4, 5, 6, etc. The next is natural numbers. Natural numbers. Natural numbers are whole numbers from 1 and above. Whole number from 1 and above. If you come to the number line, all the numbers right of 0 are called natural numbers. They are also called counting numbers. That is to say, the numbers we use for counting. Examples include 1, 2, 3, 4, 5, etc. The next there is integers. That's number 3. Integers. They are negative and positive numbers, including 0. That is negative and positive whole numbers, including 0. Examples are negative infinity to -4, -3, -2, -1, 0, 1, 2, 3, 4 to positive infinity. The next is number 4, prime number. This is a number that has only 2 factors, or you call it divisors, itself and 1. The number has only 2 factors, itself and 1. Note that 1 is not a prime number because it has only 1 factor, itself alone. You know, some students, when you ask them to mention prime numbers, they will add 1 in the list. This is not okay. 1 is not a prime number because it has only 1 factor, itself alone. The next is number 5, odd numbers. An odd number is an integer that cannot be divided exactly or evenly by 2. Examples are 1, 3, 5, 9, etc. The next is even numbers. Even numbers. An even number is an integer that can be divided by 2 without any remainder. That is a number that is divisible by 2. What I mean by that is a number that if 2 divides it, there will be no remainder. Examples are 2, 4, 6, 8, and so on. The next is number 7, rational numbers. Rational numbers, they are numbers that can be written as the ratio of 2 integers. Example is 0.25, which can be written as a ratio of 1/4. That's a rational number, a number that is specific. The next is number 8, irrational numbers. These are numbers that cannot be written as a ratio of 2 integers. Examples are pi, which is equal to 22/7, and which is equal to 3.1416. Then it is continuous. Simply put, irrational numbers, their decimal forms are not specific. They neither recur nor terminate. They continue, but they don't recur. They don't occur or reoccur. Unlike the rational numbers that even if they are continuous, they will be reoccurring. For example, 0.3333. That's an example of rational number because it is reoccurring. Example of most example on irrational numbers include square root of 2. Example, the square root of 2, which is equal to 1.1412, which is continuous. The next is real numbers. Real numbers. These consist of natural numbers, whole numbers, integers, rational numbers, and irrational numbers. What it means is that all the numbers we have listed above, they are generally called real numbers. Real numbers, that is the opposite of imaginary number. All the numbers you can write as number are called real numbers. Examples are -2, -3, 1, 2, 0.5, 3.1416, and so on. The next is number 10, which is imaginary numbers. Imaginary numbers, they are numbers that needed to find square root numbers, which would not normally be possible. You understand? For example, if you want to find the square root of -25, the calculator will give you sin error. So such a number is an imaginary number. But in mathematics, there's a way we do it. The square root of -25 is equal to 5i. We introduce an alphabet I, where I is the square root of -1. We can have it as square root of -25 equals square root of -1 times 5, which is equal to 5i, where I is the square root of -1. The next is number 11, which is complex numbers. These are those numbers that lie on a two-dimensional plane. That is, they have two components called the real and imaginary parts. Example is 5i plus 7. 5i plus 7. The next is number 12, which is large numbers. Large numbers. Large numbers are numerical digits which are considered to have higher values than those used in everyday counting. They are called large numbers. Mathematics of financial transaction. Large numbers can also be seen as numbers that are significantly larger than those ordinarily used in everyday life, such as in counting or monetary transactions. Examples of large numbers are millions, trillions, quadrillions, pentillions, sextillions, hexillions, etc. Examples in numbers are 1, then you have 6 zeros, which gives us 1 million. Then we have another one, 9 zeros, which gives us 1 billion. We have the next one, 12 zeros, which gives us 1 trillion. There is something you need to understand here. There is nothing like zillion. I've encountered this. Sometimes when I have encounter with students, I ask them to mention large numbers. Some of them will mention zillion. There's nothing like zillion. Zillion is a huge but no specific number. When you want to mention a large number without a particular amount, you say zillion. So there is no particular number called zillion. So we have come to the end of today's lesson. The next thing here is classwork. There is classwork before you. Look at it very well. Use what we have done and look at the assignment, the classwork. Do it very well and submit. I am still online waiting for the submission. I will mark it and send to you. After the classwork, the next is assignment. You have to do the assignment and submit it before the next class.